Hello, good day, my dear STEM students. So for today, we'll be discussing all about electronic structure of the atom, specifically the electron configuration and how to convert that electron configuration to its orbital diagram. Okay. So the electron configuration of an atom is the representation of the arrangement of electrons distributed among the orbital shells and subshells. Yes, you can see based on this given illustration. I have here three examples of elements uh, and their electronic configuration. We have here oxygen with atomic number 8, fluorine with atomic number 9, and neon with atomic number 10. So the atomic number of the element, you can locate that in your periodic table. So in a neutral atom, the atomic number is always equal to the number of proton. And if the atom is neutral, the proton is also equal to the number of electrons. So basically, atomic number also equals the number of electron in each given elements kung siya ay neutral form. Okay, in making electronic configuration, there are three rules that is being followed or principles that are being followed. Number one is the off-bow principle or the build-up principle, stating that in filling the orbitals, the lowest energy orbital is filled first. So, we have here this electron distribution mnemonics. This is a helpful device in order to distribute electrons in each given sublevel starting to the lowest energy possible. So, kapag ang electron pinakamalapit sa nucleus, that particular electron has the lowest energy. So, in electron distribution mnemonics, so you have this arrow, the SPDF. Simply follow the arrow. Okay, yung flow niya starting from the lowest energy, starting with 1s. Okay, and then you will distribute the electron all the way up to 7f. Okay, so this is the electron distribution mnemonics. Okay, in assigning electrons in each sublevel, so the sublevels are SPDF. S stands for sharp, P for principal, D for diffuse, and F for fundamental. So the maximum level in the maximum electron in each energy level for S sublevel, the maximum electron is 2. So pag sinabi nating maximum, hanggang 2 lang siya. Hindi niyo pwedeng lagyan ng 3 electrons ang S sublevel. Pero pwede siyang mabawasan, pwede siyang 1, pwede siyang 2, but not 3. Kailangan hindi siya mag-i-exceed sa 3. Ganun din sa P sublevel, the maximum number of electrons is 6, and then D is 10, and then F is 14. This is the maximum number of electrons that each orbital can handle or each sublevel can handle when you fill each orbital with electrons. Okay? So let us have an example. So I have here nitrogen. This is with atomic number 7. So this is a neutral atom. So basically, the atomic number also equals to the number of electron and proton. Okay, so we have 7 electrons. This is the most important thing, is to identify first how many number of electrons are being distributed in each orbital or sublevel. So based on the off-bow principle, we will start at the lowest energy possible, which is 1s. So this is 7. We will distribute 7 electrons using this mnemonic device. So we will start with the lowest energy, which is 1s. That is 1s2. Okay, so we need 7, and then follow the arrow. Just simply follow the arrow, yung flow ng electron distribution mnemonics. Okay, so from 1s, the next is orbital to be filled is 2s, and that is 2s2. So we need 7. 2 plus 2, that is 4. So diretso pa rin kayo. Hanggat hindi nyo nare-reach yung 7, diretso lang yung pagdidistribute nyo ng electron. Okay? And then, next is 2p. So, ang kailangan na lang natin, 2 plus 2 is 4. So, para maging 7 siya, you only need 3 electrons to be added. So, sa 2p, since ang maximum electron naman ng P sublevel is 6, so pwede siyang maging 3, lower than 6, but not greater than 6. So your last sublevel to be filled is 2P3. Kaya 2 plus 2 is 4, and then plus 3, and that is 7. Next example, sodium. Okay. So this time, dahil ang kailangan natin is 11, 1s2, 2s2, 2p6. Your 2p6 is completely filled already. Pero kulang pa rin. This is 10. So pupunta na kayo dun sa next sublevel, which is 3s. So ang kulang nyo na lang dito is 1. Kaya ang lalagay nyo na sa dulo is 3s1. Next, potassium 19. Okay. So this is what 2 plus 2 is 4 plus 6, 10 plus 2. Okay, yung 3s yung tayo nag-stop kanina, plus 2 is 12. So kulang pa. So baba pa kayo dito kay 3p. Okay, that is 3p6 kasi this is 18. We need 19, so diretso nyo pa dun sa 4s1. So that is the complete electron configuration of potassium. So ito yung lesson nyo dati ng grade na alam ko na ituro na to sa inyo. Okay, next. Okay, let us now make the orbital diagram. The orbital diagram shows the spin of the electron. So you cannot make your orbital diagram kung wala kayong electron configuration. So you need to practice how to make the electron configuration before you can make this orbital diagram representation of each element. So how to make the orbital diagram coming from the electron configuration of the given element? Okay, so in the s orbital, there is a representation of orbital in the s sublevel. Meron tayong one box. This is the orbital how to represent the orbital diagram of the s orbital. Okay, pag sa p, okay, so meron kayong 3 boxes. Kapag sa d, meron kayong 5. And then sa f orbital, meron kayong 7. 1, 2, 3, 4, 5, 6, 7. In making the orbital diagram of each element, there are 2 principles being followed. Okay. Number 1 is the Pauli exclusion principle. This principle states that only 2 electrons may occupy the same atomic orbital, and this electron must have opposite spins. Okay. And then the next is the Hund's rule. Each orbital must be filled singly first before pairing. So, ibig sabihin, kada isang box, meron kayong dalawang electron kasi pair nga. And this electron is being represented by arrow up and arrow down. Okay? In our first example, oxygen, with electron configuration of 1s2, 2s2, and then 2p4. So, you will going to write the orbital diagram of these 3 sublevel present in each electron configuration. So, for the s orbital, meron ka isang box. Okay? S pa rin yan. And then sa p, meron kayong 3. Okay. So, sabi sa Pauli exclusion principle, okay, only 2 electrons may occupy the same atomic orbital. And these electrons must have opposite spin. Okay. So, in the 1s orbital, the first 2 entering electron is in the 1s2 orbital. 1 and 2, the first 2. So, the electron of 1s2 is being represented as arrow up and then arrow down. It has to be pair, and then the representation of the opposite spin is the orientation of the arrow, yung up tsaka yung down orientation. Yun yung nag-i-indicate na it has the electron has opposite spin. So, this is 1s2. So, this is the orbital diagram of 1s2. Okay, the arrow represents this exponent of the sublevel, yung 2. Kaya dalawa yung arrow. Okay, next, 2s2. Okay, so the third and fourth entering electron are located in the 2s sublevel. So, dalawa pa rin yung electron, isang up and then isang down. It has to be opposite. Okay, each orbital must contain a pair, and that a pair of electron, and that electron must have opposite spin palagi. So, this is the representation. So, this 2 arrow, hindi ito yung nire-represent niya. This is the energy level, but this exponent. Okay, so 2 kanina and then 2. And then 2p4. This time, we will consider the Ohm's rule. Each orbital must be filled singly first before pairing. So kung 2p4 yan, we have 3 boxes. So yung first electron to be entering this particular orbital, yan, 1. You have to fill the orbital singly first. Okay, we need 4. 1, 2, 3 before pairing. Hindi pwedeng i-pair nyo muna yung mga electron. You have to distribute muna lahat all the way hanggang dun sa dulo ng orbital bago kayo mag-pair. That is the most important rule in filling the atomic orbital of each element. Kailangan pa-follow nyo yung Hund's rule. Let's have another example. Okay, so in this particular orbital diagram representation, we can identify the magnetic property of each element. I have here two examples of magnetic property, namely the paramagnetic and the diamagnetic, or the paramagnetism and the diamagnetism. What is paramagnetic? Materials are those that contains unpaired electrons or spins and are attracted by magnets. So if the substance is, you can identify if that particular element can be attracted to magnet if you make this orbital diagram. Ano ang condition? Okay, the magnetic property is paramagnetic kapag merong unpaired electrons. And then diamagnetic kung all electrons are paired. Okay? So kapag diamagnetic, there is no magnetic property being exhibited of that particular element. So if you're going back to this orbital diagram, pag nakita nyo ito paired din to. Ito paired. Tapos meron kayong dalawang unpaired electron kasi wala siyang kapartner. Okay, therefore, this element exhibit paramagnetism or paramagnetic. Okay? Next, neon 10. So let's represent the orbital diagram of neon. Okay? So 1s and then 2s. So dalawang s orbital and isang p orbital. Okay? So, and then distribute these two electron. Arrow up, arrow down. So, arrow up, arrow down. And then 2p6. So, isa-isa muna, singly first. Each orbital must be filled first before pairing. And then 1, 2, 3, 4, 5, 6. So, as you can see, based on the given orbital diagram, all orbitals or all electrons are being paired in this particular example. So therefore, neon exhibit the diamagnetic property of the substance. So diamagnetism to. Diamagnetic kasi all electrons are paired. Kapag merong unpaired, it's paramagnetic. So that is the important thing to know when writing the orbital diagram of a particular element. Okay?